The Village of Essex Junction's wastewater treatment facility, located in Essex Junction, Vermont, manages roughly 2 million gallons per day of influent from Williston, Essex Junction, and the town of Essex. As a part of the treatment process, this facility utilizes anaerobic digestion to biologically degrade organic solids. Through anaerobic digestion, bacteria ultimately reduces organic solids to methane gas. This gas can then be collected and used as a fuel source to produce electricity. The anaerobic digester at the Essex Junction Treatment Facility is a two-stage mesophilic co-digestion system. A two-stage digester refers to the use of two digester tanks in series where the first is constantly mixed and the second is unmixed. This allows sludge to settle and gas to rise out of solution while in the second tank. Mesophilic refers to the temperature range that is tolerated by the bacteria within the digester. For optimum operation of a mesophilic system, the temperature of sludge within the digester must consistently remain near 37 degrees Celsius. To maintain a digester temperature of 37 degrees Celsius, the Essex Junction Treatment Facility uses a combined heat and power or CHP system. In general, combined heat and power systems operate by combusting methane produced by digestion, capturing the energy that is lost through combustion as heat, and using that heat to maintain the optimum digester temperature. Co-digestion refers to the practice of adding high-strength feed to digester influent. A high-strength feed is a waste product that is particularly high in carbon concentration and chemical oxygen demand. Literature suggests that the addition of high-strength feed to digester influent correlates to greater methane yield. Since 2012, Woodchuck Hard Cider, based in Middlebury, Vermont, has been supplying the Essex Treatment Facility with the waste produced from their cider production that is exceptionally carbon-rich.
The Civil and Environmental Engineering program at the University of Vermont was contacted by Jim Jutras, superintendent of the Village of Essex Junction wastewater treatment facility, and asked to 1. Design a variable flow rate feed system for woodchuck cider waste into the anaerobic digester, and 2. Determine the effect of woodchuck cider waste on the digester and if the installation of such a feed system would be a cost-effective investment. Daily data from the past 5 years was supplied by Jim Jutras and the Essex Treatment Facility. Since the Essex Treatment Facility has been accepting woodchuck cider waste for the past year, only data from 2011 and 2012 were used. This gave 1 year of digester performance before the beginning of woodchuck addition and 1 year since addition began. This data was used to determine trends in methane production based on digester influent characteristics. Specifically, trends such as total solids loading, percent volatile solids reduction, alkalinity, and volatile acid ratio were analyzed for correlations to methane yield. Of these, percent volatile solids reduction proved to be the most closely related to methane yield and was subsequently used to predict future digester performance. The potential for overloading the digester with acidity from woodchuck cider waste was also considered. However, it was found that the alkalinity of the digester is capable of neutralizing far greater volumes of woodchuck waste than that which the Essex Treatment Facility receives.
Two alternative designs were made for the proposed feed system. Both designs incorporate the use of a programmable logic controller, variable frequency drive, ultrasonic level meter, and a Watson-Marlow SPX25 Bredell hose pump. The two alternatives differ in the holding tank size and piping diameter. Alternative 1 consists of a 6,000-gallon insulated plastic tank and 3/4-inch PVC piping, both of which are currently owned by the Essex Treatment Facility. The second alternative consists of a new 8,000-gallon polyethylene tank with new 2-inch piping. In both alternatives, the woodchuck cider feed line will be tapped into the existing 6-inch sled feed line. The analysis and design work done by the University of Vermont's Civil and Environmental Engineering team has given insight into the value and feasibility of a woodchuck cider feed system for the Essex Junction wastewater treatment facility. Due to the woodchuck cider's high methane yield after anaerobic decomposition, it is economically beneficial for the Essex Junction wastewater treatment facility to continually feed the high-strength waste into the digester. The resulting increase in methane production will correlate with an increase in electricity and energy produced from the system, thus reducing the treatment facility's usage from the power grid.